career. Several years after his graduation in 1866, he worked as a surgeon in the Franco-Prussian War, and following his service, worked as a physician in Wollstein in Prussian Posen, now Wolsztyn, Poland. From 1880 to 85, Koch held a position as government advisor with the Imperial Department of Health. Koch began conducting research on microorganisms in a laboratory connected to his patient examination room. Koch's early research in this laboratory yielded one of his major contributions to the field of microbiology, as he developed the technique of growing bacteria. Furthermore, he managed to isolate and grow selected pathogens in pure laboratory culture. From 1885 to 1890, he served as an administrator and professor at Berlin University. In 1891, Koch relinquished his professorship and became director of the Prussian Institute for Infectious Diseases, which consisted of a clinical division and beds for the Division of Clinical Research. For this he accepted harsh conditions. The Prussian Ministry of Health insisted after the scandal with tuberculin, which Koch had discovered and intended as a remedy for tuberculosis, that any of Koch's inventions would unconditionally belong to the government and he would not be compensated. Koch lost the right to apply for patent protection. Research. Isolating pure bacterial cultures. In an attempt to grow bacteria, Koch began to use solid nutrients such as potato slices. Through these initial experiments, Koch observed individual colonies of identical, pure cells. He found that potato slices were not suitable media for all organisms, and later began to use nutrient solutions with gelatin. However, he soon realized that gelatin, like potato slices, was not the optimal medium for bacterial growth, as it did not remain solid at 37 degrees Celsius, the ideal temperature for growth of most human pathogens. As suggested to him by Walther and Fanny Hess, Koch began to utilize agar to grow and isolate pure cultures, because this polysaccharide remains solid at 37 degrees Celsius, is not degraded by most bacteria, and results in a transparent medium. Koch's 4 postulates. Main article, Koch's postulates. During his time as government advisor, Koch published a report, in which he stated the importance of pure cultures in isolating disease-causing organisms and explained the necessary steps to obtain these cultures, methods which are summarized in Koch's 4 postulates. Koch's discovery of the causative agent of anthrax led to the formation of a generic set of postulates which can be used in the determination of the cause of most infectious diseases. These postulates, which not only outlined a method for linking cause and effect of an infectious disease but also established the significance of laboratory culture of infectious agents, are listed here. The organism must always be present, in every case of the disease. The organism must be isolated from a host containing the disease and grown in pure culture. Samples of the organism taken from pure culture must cause the same disease when inoculated into a healthy, susceptible animal in the laboratory. The organism must be isolated from the inoculated animal and must be identified as the same original organism first isolated from the originally diseased host.